one from Canada, the Space Flight Laboratory, and the mission of spacecraft will be taking pictures, still pictures and movies over Slovenia. So the satellite will be for experimental operations. It's not amateur satellite service, so API filing, notification, and ITU cost recovery fee are needed. And we found out that if for small countries, if we have only one filing per year, these costs are for free. So for one filing, there is not need to pay anything. Okay. So the satellite will operate on 3 frequencies. A command link will work on UHF band on 400 megahertz, telemetry downlink in S band, and the captured still images and movies will be downloaded in X band. Mission lifetime is foreseen for 1 year in a reference orbit of 600 kilometers in inclination angle of 98 degrees. So we know that for such satellite it's not needed any mandatory coordination. So we applicable this magic red book. And on this slide we can see that we can skip this middle phase coordination request on the lower part of the slide. In the yellow part, you see that it is missing coordination request, so we need only advanced publication and notification phase. Even on this phase, on this slide we can see this. So what we did till today, we submit API info to ITU. ITU published a API A form and API B form, and so these forms are in briefing, 2769 and in API B form in 2780. So I will stop a little bit in this form. So there is 14 administrations, and probably we will have the same problems with my colleague from Ficora, from Finland. It's good that we sit together for 2 days.
You are not paid for it, yeah.
But
make some comments.
Anyway, then I have a chance to discuss with my chairman in Geneva in December, and he advised me what now, and then we decided to write letters to all these administrations, and so we explain a little bit more about what's mean about these parameters.
Sorry to interrupt you. Probably you don't read it, but ask Tomo. This is extremely important. That's why, sorry to interrupt you, that they put all together questions from all administrations, what they receive. They develop QA letter, which they smashed, they sent back to all administrations. This is no, but okay, but please use this asking for a nice format, whatever. This is at least for the administration with the low number of satellites, extremely good, extremely useful. Really congratulate for this form and use it, please. Okay. Sorry.
No problem. So we are now waiting. Still, we didn't get any response from these 14 administrations, but we believe that we will get it. And then maybe in the second phase, we will come back to Geneva and ask for the help from ITU. But in the first phase, we should do this between ACOS and other administration. So as I mentioned at the beginning, but the integrator of satellite is planning to launch the satellite in the second half of year 2015, and we will notify this 30 days before launch to ITU. So maybe only one thing more, because from yesterday and from today's presentation, this lady was Tanya and Ingo. This is very, very good. We will really read these things from ITU, not ITU, UN stuff, because we are also entitled to issue at the end of the day the license. So I think this liability might be the problem, and the state of Slovenia might be liable if something happens. And so really thank you for such good occasion and such good workshop. It's symposium or workshop? It's everything.
Today symposium, tomorrow workshop.
Okay. I'm leaving today for then symposium.
Yes.
Okay. Thank you.
Thank you, Tomo. Is an example of non-amateur. That's why I put for a purpose one amateur project, one non-amateur project to show you that I feel it working. Okay, there is an effort. I know that administrations are surprised that for such a CubeSat they have to do it. There is again, size is not a matter. You do it even if for a GSO system, non-GSO, the regulatory authority have to do the paperwork. Okay, thank you very much. And now at the end, at the end is an absolutely must to give chance to the hosting administration, Czech Republic, to present their two projects, if I understand, or one. Extremely sorry. I was because I skipped. We are going to the project. Back everything. We are going to the project which is creating a lot of questions because it's a amateur planet lab project. Sorry to say, where the Belgian administration, the von Karman Institute, is planning to launch a QB50. We'll see if it's a constellation, formation, swarm, whatever.
Yes.
And for this, I'm asking Thorsten SCHOLZ to say to us a little bit about you, and if you can say to us what is clearly to say to us here. What is a QB50 from a regulatory point?
First of all, lessons learned from QB50, try it a different way. It's a rather challenging way how we set it up from the beginning, involving 50 different universities building the satellites. So that is adding a huge overset. But first, coming to me, I studied in Stuttgart aerospace engineering. Then I worked shortly for a couple of years there for a company doing orbital, or doing software for optimization of orbital trajectories. Then I joined the von Karman Institute doing first a research master after master program for 1 year. And then I was hired for QB50 as a research engineer. So that is my background. For QB50, I'm doing mostly the ground segment, so I'm involved there in in developing the system, how we collect all the data from 50 different universities. I'm also doing the frequency filing, and I'm also partially working on our satellite, which we also built in the framework of QB50 and ESA project. So let's start with QB50. Maybe not all of you know what is the purpose of QB50. It's a European Commission funded project, so it's partially funded by the European Commission, and the other part is contributions from all the consortium partners in QB50. I have also later a list with all the partners, so for your information. It's rather an international project. We plan to launch 50 satellites, 3U and 2U CubeSats into low Earth orbit. I put here also the orbital parameters, at least the rough estimated ones. So we go at a low altitude because our mission is to perform science measurements in a low thermosphere. So typically around 350, 300 kilometers. So there's no reason why we should launch a complete network or constellation, how you want to call it, in a high altitude, where you have then also debris issues, lifetime issues of the CubeSats. So we decided to go directly for the target orbit, which introduces quite a challenge to the project, since it's also only partially funded and low cost. In the framework of the project, we developed the science unit instruments, which we give free of charge to the teams, so they can integrate these science units into their CubeSat. They can also use this unit apart from the time where they have to produce data for us, also for their own mission. So there's also some teams who have asked us to have a specific science unit that they can use it to add also an additional value to their own payload. And we have also, apart from the standard science instruments, okay, in CubeSats, also in-orbit demonstration CubeSats, we have the two satellites from University of Delft, inflate sail from Surrey, and then also that is our satellite which we built, which just looks like a CubeSat, but it has only the outer shape in common with a CubeSat, because it should perform a re-entry down to ground, and for that it's quite a lot of redesign of the standard components. So it's a quite challenge on its own. For the science unit or sensors, you see here the three types which we provide. We have the FIPEX unit measuring atomic oxygen and molecular oxygen, which is developed by Dresden University. We have the neutral and ion mass spectrometer developed by MSSL, and then we have the Langmuir probes for measuring electron concentrations around the spacecraft. So we have partners in the consortium who are developing these science unit instruments, but also VKI is involved in the science campaign by doing simulations for defining the ambient or the environment around the spacecraft. As you can imagine, the atmosphere is rather rarefied, so you have only particles left around the vehicle, but still you have get some concentrations in front due to the bow shock, which is rather rarefied. So we did some simulations at VKI to see what is the actual number density increase due to the spacecraft present flying through the rarefied air. Then we correlate also these data later with the measured densities, so we can do some sort of calibration. And we also compared with available atmospheric models. And the complete goal is then to compare it also with ground-based measurements and then improve the atmospheric models, which are currently using data sets out of 20 years of history of Earth's atmosphere science. So it's rather not up to date. So we try to improve a little bit the prediction in terms of lower thermosphere. Launch segment, maybe most of you know, we have like a long history with selecting good launch vehicles. We built in the framework of the project, because one of the objectives was easy access to space, a universal deployer system by ISIS. You see there the old version, which was used before starting off the project. ISIS then developed called quad-plug system, which is rather versatile. You can deploy up to 4 satellites, 2U, 3U, or you can also group them to deploy 6U or 12U. So it's really versatile, and we can then, using these building blocks, easily adapt the complete deployment system to different launch vehicles. So as I said, we are targeted 400 kilometers due to the science constraints, but also like other constraints, collision risk with ISS, which is also launching 50 CubeSats as important. Orbital inclination is 98 degrees, so it's like standard SSO. In our case, it's not SSO, but we are secondary payload on a flight, so that's why we have that inclination, which is also interesting for science, because we want to measure above the poles and equator, so we need also a high inclination. Ground segment, so it's mostly my part. Every team has to decide or has to build their own ground segment for controlling the satellite. And we have then to interface that ground segment with a centralized version to collect all the data from the teams which they downlinked. For that,